So as you know, in the last class, we discussed viscosity and viscous forces. So you might remember I have taught you the two different cases for a viscous force. That is what viscosity. One is a solid, that is what a solid plus liquid friction. There will be two different cases. So the one case which we already studied, that is what is the formula also. So the viscous force is equals to eta into A into dV by dz. So this is what we discussed in our last class. Am I right, everybody? So this is the formula which we can make a solid plus liquid friction. So there is a two kinds of solid liquid friction. One is if you take the liquid which is like the solid object is not immersed inside, it is just contacting with the liquid surface. Means a solid surface is contacting with the liquid surface. So that is what we used to call it as a solid liquid case 1. So this is what is the case 1, which we used to say surface contact. So a surface contact, if you have noticed it, so this is the formula for finding the viscous force. Now, today's class, what we are going to study, that is what is the case number 2. So that is what when the solid is immersed in a liquid. So like if you take object, so there is a liquid. So now the object is completely immersed and then it is moving inside the liquid. Then the another theorem will come into the place. That is what we used to call it as a Stokes theorem. So we are going to study that and terminal velocity. So solid immersed in liquid. So what will happen, everybody? What does it mean? So solid moves after immersing, it will goes inside. That is what moves through the liquid. Moves through the fluid or liquid. That is what we used to say of Stokes theorem. So let us discuss what is the Stokes theorem and how it will be happened. That is all the things. So now if you have been noticed it here, so if you take the viscous force on a moving object which is inside, okay, so which is inside a fluid depends upon 3 factors. So let us discuss one by one. So remember, if it is a surface contact, like boats are moving and all, so we will say viscous force is equals to eta into area of contact into dV by dz. So that's what it is. So now if you have taken, even we have solved questions also in last class, so might be remember. So if you take here now, so today's class we are going to discuss. So the next concept is, that is what the objects are moving through the fluid. That is only we used to say a Stokes theorem and as well as the terminal velocity. So what is this terminal velocity? We'll discuss after a few minutes. So first we are going to discuss what is Stokes theorem. So remember, this is also very important concept for JEE mains and as well as NEET. And even JEE advanced, sometimes they'll ask direct question, formula based question from this. So that much important topic it is. So write it. The viscous force on a moving object inside a fluid depends on first one, shape and size of the object. Second one, speed of the object. So why speed of object? Remember, basically the solid friction does not depend on speed of the body. So here the solid liquid friction, that is what speed of the object is matters. So the friction exerted by, that is what the viscous force is depends on the how fast the object is traveling inside the fluid. So velocity of the fluid is also matters, which will affect the viscous force. But as I told you, The speed of the matter is not depends. Who is not depend? Solids. Solids not depends on speed of the body. So for example, so if let me take a solid surface, now it's very, very important. If it is a solid surface, now above the solid surface, the object is started moving. So now what will happen if this object will goes with a 10 meter per second or 20 or 30 or 40 or 50, doesn't matter. Throughout the motion, always the frictional force is remains what? The frictional force remains what? Same. You understand, everybody? The force is remains constant. So what is the frictional force, everybody? F is equals to mu into K. So this force is remains constant irrespective of speed of the object. That's why the solids does not depend on V, but here the speed of the object matters the viscous force when a solid liquid means a solid is passing through the liquid. It is completely immersed and then passing. So that is you have to remember. Clear, everybody? Understanding, all of you? Yes. So that is the second. Next, the third point. Third point is most important. It will depends on viscosity of fluid. What is the symbol for viscosity? Yesterday also I taught. What is the viscosity symbol? Eta, the coefficient of viscosity. So these are the three factors where the viscous force is depends on, where the object is moving inside the fluid. That is what passing through the fluid is depends on this. So if you take here, whenever you are talking about the Stokes theorem, so please kindly remember, we will consider the best object. Why it is means we will study in the NEET class. So if you see, we are having a different kind of objects, spherical objects, cylindrical objects. Next one, if you take conical objects, some other extra cubical objects. So different varieties of objects we have. But so remember, whenever you talk about the Stokes theorem, so please remember, you will talk about only spherical object. So why it is, we'll discuss it. So there is a reason, that is also we'll discuss. So if you take the spherical object inside, so I'm considering if it is the Stokes theorem, so definitely the what is the object we'll consider, all of you? Spherical object. So a spherical object inside fluid depends on, that is what, spherical object inside fluid, so that a viscous force depends upon, again, I choose again object. What is the object I choose, everybody? Spherical, which is immersed and is moving. Now again that also, I want it depends upon radius of the sphere. Radius of a sphere. So why it is? It's directly proportional. All directly is radius of a sphere. Second one, speed of a sphere, directly proportional. And same way, third one, coefficient of viscosity. What is the coefficient of viscosity? Anybody? Coefficient of viscosity formula. Just now we studied eta. Understand? So that is what. So viscous force depends on these three things. So with, you can see, means in the sense of the viscous force is directly proportional to radius of the sphere. Next one is what? Speed of the sphere, and as well as coefficient of viscosity. So now this is what it is. So by seeing like this one, you might be remember by this time something which you studied long back in the beginning of the 11th class. Anybody can remember? Like these things, we derived the formula for many things with the help of a concept called it as. Any ideas? Anybody? Try to remember and tell. There is a concept we studied like this. Anyone? Let the coefficient of R is A, that is what, and velocity is B, and eta is C. So at least now have you remembered how we can solve? So the coefficient of the frictional viscous force is directly proportional to R power A, velocity power B, eta power C. So we used to call something. Anybody? How to derive the formula? Like this means. Try to remember and tell me, guys.
Simple pendulum.
Yes, Rudresh? With the help of? With the help of?
Diamond.
Yes. Dimensional. Yes, yes. Remember chapter number 1 we studied?
Yes, sir.
Yes. Everybody has to remember. That's the importance of studying. Otherwise, it's not easy. Call to that Mr. Rohit, Murali, Pradeep is there. Yes. So that is what you have to remember. So now, let us take now. So if you remove the proportionality, so let me consider a k. So f is equals to k. So k is having dimensions or dimensionless or? It's just a constant. So what it means dimensionless? R power a, v power b, and eta power c. So we all know what else next can do. Just equate the dimensions. Am I right, everybody? All of you? So that's all. So let us write the units of dimensions of force. First, force is equals to mass into acceleration. What is the dimensions? Mass is capital M. So M power 1. Next, acceleration meter per second square. What is that? Meter means L power 1. Second square T power minus 2. So I'll write everybody has to solve M power 1, L power 1, T power minus 2 is equals to K, no units. K, let it be. So we'll leave it. R means what? R means what? Radius. So radius means meters. So what will happen? Radius means meters. L power 1. Write it. Let it be side. So next, L power 1 means L power 1 whole power A. So that it will turn up into what? L power A. Next, speak next. Speed. Speed is equals to distance by time. Distance is equals to L T power minus 1. So it is V power B. Next, eta. Eta is equals to what? Last class only I taught you. Check your notebooks, everybody. Eta is equals to. Yesterday only you studied array. Day before yesterday. M power 1, L power minus 1, T power minus 1. Understood? Everybody? That's all.
Yes, sir.
So L power A into LT minus 1 B M power 1, L power 1, T power minus 1 C. So now equate the coefficient. So here M power 1 into L power 1 T power minus 2 is equals to, you can split it and write it. This is L power A, this is L power B, T power minus B. This one M power C, L power C, T power minus C. So that is what. So you can take it.
Sir, L power.
Yes? Yes, Rudresh?
Sir, minus C, sir, L power.
Where? Minus C. L power, why? Yes, sorry. So M power minus C. Very good. So equate it. What will happen? Here M, here M power C is there. So M power 1 is equals to M power C. So what is the C value? Everybody. C value is equals to how much? 1. Next, L. L power 1 is equals to L power A plus L power B minus C. Am I right, guys? So which is equals to 1 is equals to A plus B minus C. Any doubt? Please respond. Clear? All of you? Next, last one. T power minus 2. So T power minus 2 is equals to T power minus B, T power minus C. So minus 2 is equals to minus B minus C. So minus B minus C. C value is 1, which is equals to minus 2. So minus 2 plus 1 minus B. So what is the B value? B is equals to 1. Okay. So bring it and submit here. So 1 is equals to A plus 1 minus 1. So 1 will get cancelled. So A is equals to also 1. So from that I'll get ABC values 1, 1, 1. So what is the formula will come? Everybody? F is equals to, that is what? Viscous force is equals to K into R power 1, V power 1, eta power 1. So viscous force is equals to K into R into V into eta. So now K value. Experimentally, the K value is, experimental value of K is equals to 6 pi. So the formula is viscous force is equals to 6 pi into eta into R into V. So please learn. So this is how the derivation of the formula will come. Anybody having any doubt, you can ask me. That's all. This is only called it as a Stokes theorem. Stokes theorem. Clear, everyone? All of you? So those who join late, you must have to understand and you have to do it. It's very, very important concept. So everybody has to learn it. Make it everybody. Any doubt, anybody can ask me. Mr. Rohit, Mr. Murali, next Kadiri, next Mani and Samya. Absent. Yeah. Understand, Mr. Udresh, Pradeep, everybody? So what is the viscous force? According to Stokes theorem, viscous force is equals to what is that, everybody? 6 into pi into eta into R into V. That is what you have to remember. Anybody having any doubt, you can ask me. Are you clear, everyone? Yes, please.
Yes, sir.
Yeah. So that is what it is. So anything doubt till here, you can ask me. So or else. So let us solve the one question so that you all make it. So question number 1. Let me take there is a fluid. So Stokes theorem means you have to imagine that what is the shape of the object, everybody?
Spherical.
Spherical in shape. Okay. So what is the reason behind? Now itself I am saying, compared to the every other object, the total area occupied by the object shape is spherical only. That is the reason we always will choose spherical object. So area. So even evening we'll study that night class. So now if you all notice it, that is what surface tension, we'll discuss that. That's fine. So if you have taken the spherical object, all of you remember. So basically if you notice it here, spherical object is, let us consider everyone. So write it. It is moving with a velocity of 10 power 3 meter per second. Next, coefficient of, that is what? Coefficient of viscosity, which is equals to 10 power minus 3 Newton second per meter square. And mass of this one is actually 6.28 kilogram. Okay. And radius R is actually R is equals to 0.5 meters. R is equals to 0.5 meters. And the given object which is immersed is, we is to consider as a solid sphere. Okay. So now the question is, find the acceleration of the object. That is only the question. Find acceleration of object. Find the acceleration of the object. Option A, 0.5 meter per second square. Option B, 1.5 meter per second square. Option C, 2 meter per second square. Option D, 3 meter per second square. So I'm giving time, just 1 minute. So if you're able to solve it, then I'll proceed further. Do it quick, everybody. Clear? Understand? Answer, please. Solve it and tell me. Do you understand, everybody?
Yes, sir.
Sir, 1.5.
Answer, how much? 1.5. So what is that, everybody? So we all knows that force is equals to 6 pi into eta into R into V. Yes, brothers, are you there? So M into A is equals to, force is equals to 6 pi into eta into R into V. So we want acceleration. So 6 into pi value 3.14 into 10 power minus 3. into 0.5 into 10 power 3. Because radius is in what? Radius is in what? Meters. Have you checked it, everybody? So velocity 10 power 3. So everything. Radius is in meters. So already we know to make it. So divided by, what is the mass of the object? All of you. 6.28. Clear? So now 3.141 are 3.142 are 2 ones are 2 3s are 10 power minus 3, 10 power minus 3 cancel. So which is equals to 3 into 0.5. So which is equals to 1.5 meter per second square. That is what you have to remember. Okay, everybody, solve it. Unless you solve, it is not going to be make it. Fastness you have to be. Naren, understand, Ryan?
Yes, sir.
Brothers, Muleda?
Yes, sir.
Okay. So now you can see left to right. So now we want to calculate at what distance it will make it. So write the question next. So there is a fluid. Okay. Now, question try to understand. So there is an object inside. There is an object inside who is moving with the velocity, initial velocity V0. What is the initial velocity, everybody? Initial velocity V0. Whose initial velocity is V0. Moving with the, that is what? Velocity V0. So after traveling to a certain distance, so it's become rest. That is what? Final velocity becomes 0. Now, whose radius is R? Whose radius is how much? R. And whose mass is M. Okay. So now, the question is, observe very carefully. So the question is, find the distance traveled by the object before stopping. Find the distance traveled by the object before stopping. That is only our question. So what is the velocity, everybody, before stopping? Find the distance traveled by the object before stopping, they are asking. So you all observe very carefully. So now, how we need to start, how we need to make it. So we all knows that they are asking us find the distance traveled by the object before starting. So if you want to find the distance, now first you tell me the object which is moving inside the fluid, either it is a constant acceleration or that is what? Uniform motion or non-uniform motion. Anybody? Dresh? The object which is moving inside, is it uniform motion or non-uniform motion inside the fluid? Yes, please. Uniform or non-uniform?
Uniform, sir.
Uniform. How? Is it uniform? So if it is a uniform means, of course, it is a constant velocity. It is a constant velocity. So that you can use equations of motion. But you can see the fluid, which is the object which is moving inside. So definitely the velocity is keep on varies. It is not uniform motion. So why it is uniform and it is not a uniform motion? Because the fluid velocity matters, fluid density matters, other the depth which is traveling matters. So this all the things will be affected. Even at the same depth, the fluid is not consistently. It is not a steady fluid. Do you understand? And the object is not at steady. Understand, Udresh? So object is moving. So that the velocity, sometimes it may travel more distance, sometimes it may travel less distance. So that's why it is a uniform motion or non-uniform motion. Yes, please. It is a
No.
non-uniform motion. So please remember, if it is the non-uniform motion, is it possible to apply the equations of motion? Anybody? So if
No,
it
sir.
is, if acceleration is constant, then I can apply third equation of motion, v square is equals to u square plus 2as. But if you notice it, here it is not a constant acceleration. So equations of motion is not applicable, because equations of motion only applicable for what? Equations of motion is only applicable for what? All of you. Constant acceleration. Okay. Or it is a uniform acceleration, but it is not applicable here. So we have to use, it is a non-uniform acceleration. So if it is the non-uniform acceleration, means we have to use some mathematical concept for finding it. What is the concept? Anybody? Yes. There is a concept, we can use it. Anyone? Mathematics, differentiation or integration? What is the concept? So we will use integration. So how to use it, you can see. So if it is a non-uniform motion, there is a two formulas for acceleration. Anybody can tell me what is the formula? First formula. Force F is equals to ma. From that, A is equals to F by m. So there is another formula for acceleration. Anybody can tell me? So if I take differentiation, for example, acceleration is equals to dv by dt. Do you remember, all of you? dv by dt. So this is the one formula. So there is another formula, which is what? V dv by ds. Remember, Rudresh, this formula?
Yes, sir.
Yes. So by multiplying both numerator and denominator by ds into ds, so ds by dt is equals to something. What is that?
V.
ds by ds is equals to, yes, please. Differentiation
V.
of, yes, v. So v into dv by ds. So this is what is the acceleration formula. So now you all can see, we all know acceleration is equals to F by m. So F is equals to what? F is equals to force divided by acceleration. So what is the force, everybody? 6 pi into eta into r into v divided by m. So that is what is the acceleration. So acceleration is equals to 6 pi into eta into r into v divided by m, which is equals to v into dv divided by ds. So both the sides something will get cancelled. What is that? All of you?
V.
Yes?
V, sir.
Yes. V will get cancelled. So what else is remaining? All of you. 6 into pi into eta into r divided by m, which is equals to dv by ds. So now you all notice it. This 6 into pi into eta into r divided by m, everything for a given object remains constant or varies? Remains constant. So let me consider this whole thing, which is equals to a constant k. So then k is equals to dv by ds. So now, if you all notice it, so if you take this constant, so what will happen, everybody? So constant k is equals to, so as it, if you notice it, object is going to come to rest. So object is going to come to rest means it is decreasing. Decreasing means what? Negative or positive or? Everybody? Negative or positive? All of you? Negative. So it is whole acceleration is negative. So k is also negative because it is decreasing. Decreasing, please remember. So minus k is equals to dv by ds. So now you all can see, we will write it dv is equals to minus ks into k into ds. So apply integration concepts on both the sides. So what will happen, everybody? Velocity varies from where to where? Initial velocity is v0, final velocity is 0. So where to where it will varies? Anybody? v0 to 0. Next one, distance. Distance varies from where to where? Initial distance is 0 and final distance is what? Final distance is what? Yes. Understand, Ra? Please respond, everybody. So that is what. So differentiation of dv is v. So v roots is 0 to, sorry, v naught to 0. Next, the same way differentiation minus k is constant. So integration of ds. What is the integration of ds? Which is equals to s. Am I right, everybody? So which is equals to g to s. So 0 to s. So which I will substitute 0 minus v naught, which is equals to minus k into s into d power 0 to s. So if I substitute it, we'll get v naught is equals to minus k into s minus 0. So now both the sides minus minus will get cancelled. So s is equals to v naught divided by k. So we all know k value. Just now we studied. What is the k value? Anybody? 6 into pi into eta into r divided by m. So bring that and substitute it. So v naught divided by 6 into pi into eta into r divided by m. So m will go up. If m will go up, what will happen, everybody? Displacement is equals to v naught into m divided by 6 into pi into eta into r. So this is only the formula for calculating distance traveled by a body. Distance traveled by a body deeper inside the fluid. This is what you have to remember. Anybody having doubt till here, you can ask me. So it's very, very important. So I hope you all clear. It is not a uniform motion. If it is a uniform motion, we can apply the equations of motion for calculating the distance or acceleration or what direction. So it is actually what? Non-uniform motion. Okay. So that's why we are using if it is a non-uniform motion, so that what will happen, everybody? Acceleration is equals to, we are having two formulas. One is dv by dt. Another one is v dv by ds. So from the beginning of this class 11, we are studying this. So with the help of that, so what we are going to do it, everybody? So find the distance traveled by the object before stopping. So what is the distance? Distance is equal to liquid. Acceleration is equals to v dv by ds. And acceleration, you can see acceleration is actually, it is decreasing, so that the value will come what? Negative. So minus of 6.5 into eta r divided by m is equals to dv by ds. I'm considering this, all these are equal. So constant remains constant. So I'm considering as a k. So then what is happening, everybody? All of you? Yes, please. So k minus k is equals to dv by ds. Then if you integrate it over. Clear, everybody? Yes?
Yes, sir.
Yeah. Completed, everybody till here? Completed, everybody? So what is this distance traveled by the body, which is equals to v naught into m divided by 6 pi into eta into r. That is what you have to remember. Any doubt? Anybody can ask. Completed, everyone? Yes, please.
Sir.
Yeah. So now, the next concept which we are going to study is actually the terminal velocity. Terminal velocity. So terminal velocity is more related to our free fall case. So this is actually traveling inside the water or a liquid, actually fluid. But just basically you consider a free fall case. So if you all notice it, when the object is thrown upwards, so we all know that it is been thrown up. It has been thrown up in the sense of initial velocity is maximum. So when it is object is keep on going up, velocity will be keep on decreases. So it will reaches to the maximum height. What will happen? Final velocity become what? 0. Okay. Same way, when object is in the case of free fall, if you all notice it, so let me take different segments. So this is the point A, this is the point B, this is the point C. Let me take point D. See, if you understand this, then the terminal velocity concept is very simple. So if you take object is fall from this point, so initial velocity is what actually? If it is a free fall, initial velocity is what? Initial velocity is 0. Okay. So now before touching the ground, it is having a what? Maximum velocity. Am I right or wrong? So before touching the ground, it will be having a maximum velocity. General case I am saying. Now when the object will comes to here, definitely V is equals to V naught. So it is not equals to 0. When the object will comes to this height, so V become V2. So now definitely you tell me what is that? V2 is greater than V1 or V1 is greater than V2? Anybody? V2 is definitely greater than V1. So as the object is coming down, of course, the acceleration remains what? Acceleration remains constant. That is what acceleration due to gravity. So G values remains constant, but the velocities keep on changes. That is what, if it is before touching the ground, it will be having what? Velocity. Let me take V3, it is the maximum velocity. So that is what it is the case of free fall. Am I right, everybody? Free fall means, all of you please respond. So now, if it is comes to the terminal velocity, so let us discuss what is the terminal velocity. I think meeting is going to end. Come back and we'll join. So if any object is dropped in the fluid, or if you take in the liquid, then let us see what is the terminal velocity and when it will be, when we can say it is a terminal velocity, and all we're going to discuss now. So make it everyone. This try to revise and keep it.